Okay, and I wanted to end with probably the big story of what will be one of the big stories of this year, I expect. And that was just announced at a press conference this afternoon that there's a nearby star about 40 light years from the Earth, and they have discovered or confirmed the presence of 7 Earth-sized planets orbiting this star. And this is called the TRAPPIST-1 star system, or planetary system. And I have to write this down because I'd never remember it. TRAPPIST stands for Transiting Planets and Planetesimals Small Telescope. And this is a telescope in Chile. And in May of last year, they released results where they had seen 2 planets, possibly a 3rd planet, orbiting this small star. And it really is a very small star. It's about the size of the planet Jupiter. And so what they've done today, or announced today, is they've actually confirmed now 7 planets, not just 2. And I'll give you an idea here of the scale in just a second. But this gives you some details on how these observations
Imagine a place with not 1, not 2, but 7 Earth-sized planets all orbiting a single star. It's not just science fiction, thanks to a new discovery by NASA's Spitzer Space Telescope. TRAPPIST-1, an ultra-cool dwarf star just under 40 light-years away, plays host to this incredible collection of planets. In 2016, astronomers using the TRAPPIST telescope at the La Silla Observatory in Chile first identified 3 Earth-sized planets here. The discovery warranted extensive follow-up by Spitzer, whose infrared detectors are particularly sensitive to the cool glow of this tiny star. Spitzer devoted over 21 days of nearly continuous observations to TRAPPIST-1, pausing only to send data back to Earth. It was looking for tiny dips in the star's brightness when the circling planets pass in front of the star or transit. From this extensive data set, astronomers confirmed 2 of the 3 previously reported planets and found the 3rd was really 3 different ones. Plus it discovered 2 more for a total of 7. The transits tell us a lot about these planets, including their size, orbital period, distance from the star, and for some of them, their approximate mass and density. NASA's Hubble Space Telescope followed up by studying the transits to look for the chemical fingerprint of hydrogen gas in the exoplanet atmospheres. While its search continues, none has been found yet, adding support to the idea these are all rocky terrestrial worlds. That makes this a planetary system that is both familiar yet exotic. It is likely most, if not all, of these planets perpetually keep one face pointed toward their star, a phenomenon called tidal locking. This would create large temperature gradients across their surfaces and offer the possibility that liquid water could exist on any of them under the right conditions. Moreover, if you could stand on the surface of one of these worlds and look up at your neighboring planets in the sky, they would at times appear larger than our moon looks to us. That's because TRAPPIST-1 is only a little bigger than Jupiter, and the TRAPPIST-1 planets orbit only a little farther apart than Jupiter's moons. Interplanetary trips here would be measured in days, not months or years like in our solar system. For now, we can only speculate what these exoplanets might be like, as we still know relatively little about them. Upcoming missions like the James Webb Space Telescope will study the TRAPPIST-1 system in greater detail and uncover more clues about the atmospheres and compositions of these 7 Earth-sized worlds.
Okay, so just a little bit more detail here. So here's the layout of these 7 planets, and just to get a feel for the scale compared to the solar system. So they're fairly close to their mother star, and you can see what the orbits of the large Jovian satellites are for Jupiter, but sorry. You can see that the entire planetary system is actually contained very comfortably within the orbit of Mercury if it was in our own solar system. And this is just comparing the sizes and the orbital period, or the year, for each of these. So in our solar system, Earth is 1 year, 365 days. Venus is 224 days, roughly 88 days for Mercury, 687 days for Mars. And measured in astronomical units, where 1 astronomical unit is the distance between the Earth and the Sun. Mercury, our closest planet, is about 0.39 AU. Looking at the TRAPPIST system, the closest one is only 0.01 AU. The most distant one is about 0.06, so they're all considerably closer than Mercury is. Orbit very quickly, ranging from 1.5 days up to about 20 days. The diameter compared to Earth, they're all roughly Earth size, so 10% larger, 5% larger, about 75%, 90%, essentially the same. Since we're able to measure the size of these objects, and then the Spitzer telescope can look at determine the mass of the objects, they also can come up with the density of the objects. And they all appear to be rocky, possibly with some water mixed in. And so the exciting thing is when we look at how close they are and the properties of the star, is the middle 4 of them are within the what's called the habitable zone. It's in the area, the distance from the star where you can have liquid water. And so at least 4 of them are in that zone. And of course, what gets people really excited about this is if you have liquid water, the possibility for life existing there is significantly enhanced. The movie, the video mentioned the Hubble observations. They've looked for signatures of hydrogen in the planets, and what they do is they track it as it moves across the disk of the star, and they could get spectra of hydrogen if indeed it existed. They haven't found that, and that would indicate that these are terrestrial objects, not larger planets that, like Jupiter, that would have very thick atmospheres, primarily made out of hydrogen. And so they'll be doing a lot more observations of this system. When the James Webb Space Telescope is launched in late 2018, it will be able to do spectral observations of the individual planets and could determine if indeed there's water there, look for things like carbon and silica and various metals that would have unique spectral signatures. So I'm sure this is going to be an ongoing story, but it's a very cool result. We've found terrestrial-sized or Earth-sized planets on a handful of other stars, but to have 7 of them around a single star, and to know that at least 4 of them are in that zone where you could have liquid water is pretty powerful result. And so this is just an artist rendering of the outermost of those moons in the habitable zone, and you can see the parent star, and here's the inner 3 nearby planets that are also in the habitable zone. And as they said, if you were standing on this planet, the nearest other planets would actually be larger than the full moon from the Earth. So that's definitely late-breaking news, and those are the things that we like to bring to you, because you'll certainly be reading about this in the newspaper tomorrow.